Okay, hello. This is about this video is about second question in homework 4. This is another interesting case. In the second question, what I'll think about is, so you have like well-behaved exogenous regressor, but suppose that what happens, you just have extra instrument, right? So if the regressor was endogenous, you could use the instrument. But what happens? Actually, the regressor did not have any problem. Does not have any problem. Then still, can you use the instrument? Does it help? And simple answer is no. If the original regressor is exogenous, obviously, like a like instrument uh, is useless even if you have a lot. So we are going to prove that, right? So then, as you remember, we learned two different ways to identify or estimate the linear regression with the instrument. One was like two-stage least squares, or like a fitted value approach. I call this fitted value approach in identification, and in estimation, I call this two-stage least squares. And the other was moment condition approach, or the GMM estimation, right? So in the second question, part A is fitted value approach, and part B and C are about moment condition approach. Okay. Again, so in case if you have not read the question, please pause and read the question carefully and think about if you can do this. All right. If you can try it by yourself, and if you can handle that, handle the questions. That'll be great. If not, then come back. Okay. So think about A. Um, so remember, in general, like so. So in general, let me write down the general setup. The general setup we learned in class. We have this main regression, and the first stage regression usually goes like gamma 0 times g plus eta, or like xi. Okay, so remember, in the first stage, an endogenous variable, the vector of endogenous variables will be estimated on the instrument, and then calculate the fitted value, say hat gamma zi. This is the fitted value, and regress y on the fitted value. This is the fitted value approach. Okay. In our case, in the homework, the regressors is simply the scalar xi, and the instruments are vi. I will use this notation throughout this homework, throughout this question. By the way, to enter vector or matrix, you have to click this and 2 rows, 1 column, and set this, and then you have 2 by 1 vector notation. Okay. V is an instrument. So in the first stage, we regress x on V, which is like two regressors, right? Two instruments, x and z. So we are going to regress x on x itself and z. And what I want to show you, I want to show that the resulting fitted value will be same, right? If the fitted value from this regression, like regression is the same as the just if there is no residual, then the second stage regression will be the same. Like regressing y on x or regressing y on x hat will be the same if x equals x hat. That's what I'm going to show. By the way, yeah, I'm sorry. I was just wanting to check if I'm recording this. um, okay, so I will show this. How to do that? Um, you know that. Let's think about. So like gamma 0 xi plus delta 0 like zi plus xi. And by the way, of course, because we assumed everything is mean 0, so we ignore the intercept. Does not matter. Okay. Let's think about this first stage regression. I will show that, and we know that the coefficient vectors is expected value of v transpose inverse. Yep. We have studied this formula many times in chapter 1, right? So x prime inverse and xy, this is how we obtained it. And you know, um, we can rewrite this as 2 by 2 matrix xi squared, excuse me, and here xz, and here z squared z, right? And it's inverse, it's 2 by 2 inverse, and here you can rewrite this as expectation xi squared and expectation xi zi. So basically there are only 3 different objects, x squared, z squared, and their covariance, okay? So you can just expand it like do some algebra and invert this matrix and calculate that. And then that is tedious algebra, but you will obtain interesting result. It will be 1 and 0, right? So you will obtain that. It is doable. So if you get 1 and 0, then clearly you will get 1 and you will get 0 here. But this is sample, like this is population level analysis, right? I explained this in the population level as if everything is known. True parameter is calculated like this, but even in the finite sample, you may do the same thing. Like you may say the same thing, like so not the true value, but your estimator het gamma, het delta will be not just expectation, but right. Let's put it here. Replace the population expectation with sample average. And inverse goes the same way. And so you get something like this. And of course, these expectations must be replaced by sample average. Still, you will get the same 1 and 0 in the end, right? So it's tedious algebra, but I want to say that this is different from this one. In this context, you have to show this, not the true parameter, because I want to show that even in the finite sample, the OLS estimator is no different from the instrumental variable estimator. Okay, so Okay, I'm going to continue this in the next video from part B. Okay. Okay. Thank you for watching. See you later. I will come back soon.